Hello everybody and thanks for joining me. My name is Behnam Mobaraki, Assistant Professor from International University of Catalonia in Spain. In this presentation, I will talk about our recent work on a smart low-cost monitoring system that helps to evaluate the energy performance of buildings. As you may see on the screen, the title of the paper is Implementing an Intelligent Monitoring System to enhance energy efficiency and support decarbonization in sustainable buildings. The authors of the paper are Abdullah Mubaraki, Mojdeh Nikufam, Zahra Mubaraki, Ehsan Hosseinzadeh Fard, and myself, Behnam Mubaraki. In the first step, I will introduce an introduction. Then we'll talk about the thermal monitoring system, IoT heat. The third part is the test description, and we'll conclude with a comparative IoT heat results. We all know that improving the energy efficiency of buildings is one of the main goals in reducing global carbon emission. One big challenge is understanding where and how heat is lost, especially through walls, roof, and windows, which are called building envelopes. Older buildings, in particular, often suffers from poor insulation and thermal breaches, which cause a high energy consumption and discomfort in buildings. That's why researchers are always looking for a simple, affordable, and reliable ways to monitor and improve the energy performance. There are several approaches for evaluating how well a building retains heat. The most common one is called heat flux meter method. It directly measures how much heat flows through a wall. But this method needs an expensive equipment, stable indoor and outdoor temperature, and careful setup, which makes it hard to use on buildings with low budget. In a newer, let's say, or simpler method is called temperature-based method or TBM. It uses three temperature parameters, which are temperature inside the room, temperature outside the room, and finally, the temperature on the inside surface of the wall. Using these values, we can estimate the U value, which tells us how much heat passes through the wall. And it's important to mention that the TBM doesn't require expensive heat flux sensors, which makes it a great option for low-cost monitoring system. In this study, we developed an intelligent thermal monitoring system called IoT Heat, which stands for Internet of Things Hyper-Efficient Arduino Transmittance Meter. It's a small, affordable device made with an open source hardware and low cost sensors. It collects temperature data from both inside and outside of the buildings, calculating the U value using temperature-based method, and sends all the data to the cloud for real-time monitoring and real-time post-processing of the data. Our system has two main parts, as you can see. Uh, it has an indoor module which with a contactless infrared sensor to read wall and room temperature, and the outer module which measures the outside air temperature. All the sensors, as I mentioned before, send the data to the cloud through the Wi-Fi communication protocol. And this allows building manager and research group to monitor the thermal performance in real time from everywhere. We installed IoT heat system in a residential commercial building in Barcelona. The sensors were mounted on inside and outside on a wall with a good exposure to the outdoor conditions. The systems run continuously for 7 days, collecting the temperature data at regular intervals, and this gave us an enough variation in temperature to calculate reliable U values using temperature-based method. And here you can see how the indoor air temperature and also the surface wall temperature are changing over the time. The indoor temperature ranged from about 15.5 degree of Celsius to 24.7 degree of Celsius, while the wall surface temperature ranged from 15.4 degree of Celsius to 21.3 degrees of Celsius. And these differences help us to understand how well the wall of the building was resisting the heat flow. Uh, we then use the collected data to calculate the U values through the monitoring period. You can see here that the temperature difference between inside and outside was small, thus resulting a U value fluctuating over the time. But with a higher temperature difference, let's say from 10 to 13 degrees, the U values estimated let's say, became more stable and reliable. And our average result was about 0.97 watt per square meter degree of Celsius, which is so common for walls with poor or no insulation. And as a conclusion, I would like to mention that we have introduced a smart and affordable monitoring system that use temperature-based method to estimate heat loss in buildings. It's based on low-cost sensors and open source tools, making it scalable and accessible. And finally, our field tests show that it works well in real condition and provides valuable data for the energy audit and retrofitting planning. Thanks a lot for your attention, and if you have any question, feel free to contact me.